Rohan from NVIDIA. We've been working with NVIDIA for, I feel like, almost like a decade now. So we helped like start the NVIDIA RAPIDS project. Nowadays, like GraphRAG, LLM, just so much cool stuff going on. And so it's just like, it's almost like Christmas every year. It's like, it's wonderful, just whatever NVIDIA is bringing. So if you haven't heard about GraphRAG, this should be a delight. So.
Yeah, thanks, Leo. Thanks for having me. So quick intro from my side. So I've been at NVIDIA about 4 years now. And so half of that time was on the autonomous vehicles team, and the other half has been working on GenAI. So alongside customers. And so my role is a senior solutions architect role. So I'm going to talk about how we've been using knowledge graphs alongside some customer projects, specifically like accelerating it with NVIDIA's QGraph solution. And yeah, so I think, one sec. Oh, it's not connected. It's okay. It's okay. Yeah. So yeah, I think immediate thing what I'm going to talk about is how we used LLMs to extract triplets. And so triplets are just entity one relation entity two. And the way we're doing that, like this is a basic refresher because this is something which again we've been using for some educational content. But basically, we're trying to connect up different entities with the edge information, which we're extracting from unstructured data. So we're actually taking in, so in this case, we're looking at a finance domain example. And so we're trying to take in, data from sources like news information, news feeds, which is coming in. And we're trying to go and split that up into, for example, ExxonMobil is cutting spending on oil and gas. And so ExxonMobil is a company, cut is the actual relation there, and then the activity is the spending. And so we're trying to take that information from unstructured news info, and we're going and adding it into a knowledge graph. And so this concept of taking it from unstructured data and putting it into a graph, we're doing that with LLMs. And coming to the pipeline which we had built out, we had actually taken the SEC 10K data set. We were doing text extraction from JSON files, which we created from that data set, using like relatively simple prompt engineering at the time. So we were using the Mixtral 8x22B model. And then we're creating these graph triplets and then later adding it into both like a graph representation, which is in NetworkX, and also a graph database for persistence. So that was being done with ArangoDB. And both of those integrations have been accelerated on the GPU by QGraph. And so I'll talk a little bit more about the performance characteristics, but once you have that actual knowledge graph, you can later have a user query against it, and you can run various like easy to difficult versions of graph analytics on top of that knowledge graph. And so we were doing that with LangChain, and then like you could optionally add reasoning and other details into that. So looking at the pipeline, another aspect which we focused on was to go and fine-tune the triplet extraction model. Because if you look at the approach which we're using, we're actually doing this on all the unstructured data which we have. So we're pulling in data from the GDELT financial API. So that actually has updates about global news every 10 to 15 minutes. We also had earnings call transcripts, we had financial documents, we had news articles, so various financial information, and we needed to actually convert that into these triples which we store in the GraphDB. And so initially you can start out doing that with some sort of LLM, and that may be like a foundation model which is just designed to do that triplet extraction. But later when you want to run this on the entire scale of your data, you'd probably want to go and fine tune a model to just do that specifically. And so we had a small sort of data flywheel in place wherein like we would do a quality check. If we're able to get good quality triples, we would go and add it back into the GraphDB. If we have bad triples, then we're using that information. We're trying to correct that either with a human in the loop or automatic correction with a more powerful model. And we're using that synthetic data to go and create a fine-tuned LoRA-based model. And then that generally, like what we've seen is that we started off with a 70 billion parameter model, but we were able to bring down the cost and the performance into an 8 billion parameter model. So almost like a 10x improvement just by doing this data flywheel process. And once we actually have that knowledge graph which we've created, all of the algorithms and things which run on it are going to be accelerated on the GPU. So I'll talk again a little bit more about that in the subsequent slides. Looking at the triplets themselves, what we're doing is taking arbitrary, text content, so news articles, and we're splitting them up into these sort of triplets, as I mentioned. And in terms of knowledge graph strategies, there are a few approaches which people generally look at. So then like you can of course search beyond a single node by doing multi-hop expansion. So that requires these graph algorithms, which again are going to be accelerated. So you can look through beyond just doing a single step search, you can do multi-hop expansions, and then you can retrieve whatever is relevant. So a subgraph which is relevant to your query. You can of course apply like GNNs and other things on top of the graph to identify the most relevant nodes. You can also get information from, let's say, like you asked about two different entities. You can look at the shortest path between them, identify subgraphs around that, and so on. And all of this is also, again, improved and accelerated when you're looking at applying reasoning models and other things. So then it lets you do that multi-hop reasoning with a single retrieval, which is not always the case. When you're looking at like agentic systems without a knowledge graph, you'd need to do this over multiple steps. And so this actually speeds up even an agentic workflow. And why would you want to do this on a GPU? So we have seen that we have a few benchmarks when comparing CPU versus GPU. There's actually this blog post where we have accelerated NetworkX to do zero code change acceleration. And so if you look at the code, all you have to do is set an environment flag for NX QGraph autoconfig as true. And what it does is it's able to automatically use your already installed NVIDIA driver and other things. And you're able to see that the speed can be between like 70 times faster to almost 485 times faster compared to a relatively powerful CPU-based system. So we're looking at an Intel Xeon with 56 cores, and we're looking at an A180 GB for the GPU. And so A100 again is not the latest; it's 2 generations old. The CPU is still like relatively powerful. So the point is, since we are already doing a majority of things in agentic AI with LLMs, which are going to run on this GPU, you also have the potential to move your graphs to the GPU and then leverage all of the advantage which you can get with that. Coming to the fine-tuning aspect, so what we were able to see is that this is all from 2024, so that's why the models are slightly older than what you would be used to now. But what we did is pre-GTC, so GTC is our GPU technology conference, so that's around March. What we had done is we started off with 70 billion parameter models, so the Llama 2 series. We were able to get improvements by switching to the 8x7B MOE without any effort. We were just doing prompt engineering at the time. After GTC, we started looking at optimizing this. And so we looked at the 8 billion parameter. We were able to get much better performance just by the generation jump. After that, we started using like LoRA-based methods and also tricks to go and do that flywheel. And then that caused us to improve our accuracy for triplet extraction almost to 100%. The data set which we had is relatively small, but we were able to almost max out accuracy on that data set. And this is going to be designed as a fine-tuned LLM just to do finance triplet extraction. And in terms of problems when it comes to doing that, there are some failures which you expect when you're getting, parsing these results. You might find apostrophes or different, like very long outputs, which might cause it to be incomplete and inaccurate. And so the way we're trying to improve this is do some, post-processing and prompt cleaning at the end so that we could actually do that, flywheel in place. In terms of the triple generation flow, what we had to do is just a few basic things. We were correcting those apostrophes. We were trying to do post-processing of that triplet to go and create that final like flywheel, basically. So these are just showing some examples of how correct or incorrect examples would look like. So in terms of the customization itself, like as I mentioned, we have this concept called NVIDIA NIM. So that's the inference microservice. And what it lets you do as an option is to provide multiple LoRa adapters, so low rank adapters, which you can automatically swap in and out depending on the user's input. So let's say you have a single model like 8 billion parameter without fine tuning. You can set up like 10 to 20 different adapters for various different use cases. So you could have one which is finance, one which is healthcare, all the different domains in your company. You could have these autonomously automated out to your base model depending on your user's input. And then all of these are cached on the device. They're much smaller, like 10 to 20 MB per model. You can do this very quickly in production. And I think the rest of it is going to be walking through like how you would have this for dynamic graphs, which many people were concerned about. Like when you have this updating in time. You might have like the storage being hosted as like either CSR or dynamic CSR for QGraph, and this can cause issues when you're trying to update these in real time. So the way we're doing it right now is that you would have one which is hosted in memory as a graph database, and you would have one which is persisted, and then you would be either doing a pointer swap or you would be changing some of these at like relative intervals in time. So not necessarily immediate updates of that graph. So this is again going to describe some of this. Like you have a background graph wherein like your users are interacting with that directly, and you have a query graph which you can query against, and then you would be swapping these when there are no updates being made. And so we had mentioned like we are working with a few different companies. Arango is one of them, and they have that same NetworkX integration which lets you use that for the GPU. And in terms of evaluation, I think this is an important problem. Like when people talk about doing vector-based RAG versus graph-based RAG versus like, you know, all of the other approaches, how would you evaluate it, and like how would you want to use this over something else? So in terms of evaluation, we were looking at two different approaches. One has been this RAGAS system, so RAG assessment, and then the other was using synthetic data to create and then reward different scores of a model. So we created a synthetic data set using this 340B reward model, and then later we scored it based on like these 5 different attributes which you have. And similarly, RAGAS has a setup which allows you to score it on different metrics. So based on that, like we had published a paper which was kind of combining the vector and hybrid graph approaches. And I think some of this is again more on the supplement side. So like when you want to actually create a knowledge graph, you want to also be able to update or maybe predict like the different links within that graph. So if you have some entities and then you have like a subsequent entity, do you know if there's a relation between them or not? And how should I, you know, process that? How should I plan it, and so on? So then some of those, like we're looking at applying GNNs, so PyG, the PyTorch geometric framework. There are other teams who are working at looking at applying or using GNNs to predict whether there's a relation between some entities. And then like some more classical methods have been like using matrix factorization or page rank based approaches. So yeah, I think that's pretty much it from my side. This is like the broader team who's worked on like a lot of these things, and we've also presented this at this year's GTC. So I can take questions. Thank you.
Probably a pretty basic question, but when you're parsing the data and you're extracting these entities, how do you make sure that for some of the data is like categorical, whereas like you have 5 potential options, how do you map into those 5 options in your parsing process?
Yeah, that's a good question. So there's a couple of ways. Basically, what I would say is when you go back to the actual extraction here, like you would actually want to define the like schema or the, you know, ontology of that data. And then when you're defining that as a prompt, like you can also go and enforce that the output of the LLM remains within that schema. So then you can go and say that the output should be within these particular buckets or types of response. So the way we are creating those schemas right now with LLMs has been to kind of look at your overall data, do some sort of clustering, and then predict or suggest. But then you always need some domain expert to go in and like reevaluate that based on that. Yeah.
I have a question about the synthetic data set. I don't know if it was on the slide with the LoRA adapters or the one after.
Evaluation.
Yeah, the reward modeling. So are you generating the synthetic data set using an internal tool or a third-party tool?
Using, sorry?
An internal tool or a third-party tool?
It's using a model, like again,
okay,
LLM
so
designed for doing synthetic data.
Gotcha.
Yeah.
Maybe one more is, again, selfishly, if you look at, so this was a very traditional knowledge graph focus of entity extraction to knowledge graph, and then presumably some sort of retrieval directly on the knowledge graph. A lot of GraphRAG work is looking at doing more like summary indexes, where you have like a meta summary index on top of the graph. Imagine drawing circles. Have you started, or have you been looking at the more summary index perspective?
Yeah. So I'm not sure if it's summary index per se, but like one approach which like another team has worked on has been to apply like GraphRAG on top of video data. So they're able to take, like we have this blueprint called video search and summarization. And what they do is they're able to take like 1 hour, 2 hour long videos, and they're able to very accurately like summarize the entire thing. And the way they're doing that is they're able to take objects and relations within that video. So at different timestamps, let's say like it's a warehouse video, and you're seeing like someone walking and picking up an object at some timestamp, then dropping it at some other timestamp, walking through a certain aisle, all of that detail. They're able to use that, put it into a graph, understand the entities and relations within that video, and then summarize, and you can query like what did this person do at this timestamp and so on. So I would say that is kind of the approach where they're applying it for summarization, and using like metadata as well, but I'm not sure if it answers it fully, but yeah.
No, thank you. I guess maybe one more question then on top of that, just as we're waiting, is within that, so for context, we have like a very similar pipeline where we have like logs or news or key events we're tracking to build almost like an auto wiki. One of the things that we find interesting, the summary index case is kind of how you talk about for regular, is actually dynamic updates so that we don't have to re-index everything. And so when you're doing that summary index work, is there aspects there about the incremental updates basically for the summaries?
Yeah, I think right now they are mostly indexing on static videos, like very large, let's say 1 hour long video of which you've already indexed. But then I think the next step they're looking at is for the dynamic case. In our case, what we are doing is we are continuously like updating the graph, but then that's more for like the news content and stuff. Yeah.
Awesome. Well, thank